experimental and theoretical probability. Here's the good news. We kind of talked about this a little bit already on Friday. Okay. We talked about how to find probability, like with spinners and dice, and what else did we do? We talked about cards a little bit. I like the spinner because that's kind of... Okay, does everybody remember how to find it? So let's say, I don't know, let's say I have my spinner. Wah! There it is. Okay, and I have 4 equal sections. This is a yellow, this is a blue, this is a... Let's make this a... Oh my gosh, what's happening? I'm going to have to reorientate. Red, and let's say this is a blue. What's my probability of spinning a blue out of here? Half. 2 out of 4, 1/2, right? What's the probability of not spinning a yellow? No, I have a yellow in there. What's my probability of not spinning a yellow? 3/4, 3 out of 4. What's my probability of spinning a black? 9, because I don't have any blacks in there. Okay, does everybody remember how this goes? Okay, because today's about the same thing. Let me orientate this quick before we get started. It's funny how some days I don't have to do this, some weeks, for weeks I don't have to do this. And all of a sudden, a few days, oh, I have to. Is that better? Yeah, it's a little better. Oh no, what's happening? I think I'm going to have the internet come up now. Gosh. Alright, maybe it won't. Alright. So uniform probability. First vocabulary word. Uniform probability is when you have the same exact outcome of everything happening. So, and if I look at my picture here, so the same probability, each thing has the same probability of happening. Each outcome has the same probability. And then I have a picture up here, so you can kind of see what I mean by this. Now let's take a hard look at my will A and my will B. And don't even look at the colors, look at the words inside. Okay? You win, you lose, you lose, you win. So we're talking about winning and losing. So if they spin it, they either win or they lose. It doesn't even matter what color they land on. Which wheel is probably the most fair? Yeah, Jasmine. Why would B not be fair? Read it. Yeah, look at your bigger chances of losing. Look at the size of each piece. If this was a pie, I mean, if you look at B and you say, well, I still don't understand, could you not split this into like 3 more places? And then how many more sections of you lose are there compared to you win? A lot. But if I look at this one, are each one the same size? I mean, I could go, oh, I could just keep splitting them. And guess what? They're all going to be the same size. So the wheel on here that has the most uniform probability will be wheel A. Okay, now what is theoretical and what is experimental probability? Okay, so we kind of talked about this a little bit. Okay, so theoretical is the actual probability. So like in theory, what's going to happen? What's going to happen on paper? Okay, what's going to happen on that paper? It's telling me that this should happen. In theory, this should happen. And experimental is basically doing an experiment, figuring out what your outcomes are, figuring out what your probability is based on the experiment that you did. What actually happens? So at the beginning, you can kind of make a guess. This should happen. And at the end, it might be totally different because your experiment's telling you something different. Didn't we do that with the dice? We kind of saw what our probability was compared to what should happen and what we actually did on our dice on Friday. In theory, what's going to happen, what should happen on paper. Experimental probabilities, you actually do an experiment, and then you get your results and figure your probability from there. So we're going to do some experiments this morning. We're going to flip some coins and draw some cards, and we're going to see what our theoretical versus our experimental is. But first, we're going to kind of do some problems like you're going to have in your homework, okay? I'll show you some problems like Alright, so first story problem. There are 15 girls in our class and 5 boys. I just made this up. Okay, this isn't real. This is just fake, okay? And in this class, what is the theoretical probability of me picking a boy's name out of a hat? Okay, so first of all, how many chances do I have in that hat, Cadence? I have 20 chances in that hat. What's the theoretical probability that I'm going to pick a boy's name? How many boys do I have? 5, okay, which reduces to 1/4. I have a 4th chance, 25% chance of picking a boy's name out. Okay, now let's say I put all these people's names in. Might that happen? What if it doesn't? Is that okay? That would be your experimental probability then. Okay, so theoretical is what's on the paper. What is on the paper? The experimental would be if you actually did the experiment. So what about girl's name? What would my chances be if I had a girl? 15 out of 20, which would be 3 out of 4. Who has a better chance? Obviously the girls, but is that a 100% chance? Do I know I'm going to pick a girl's name out? It's kind of like if you know it's going to rain or not. Remember how we said it's an 80% chance of rain? Is there a good chance it's going to? But is there a little chance it's not gonna? Yeah, so you have to know that, yeah, there's a good chance, but there's also a good chance it's not going to happen. Okay? What do I have down here? Oh. Will the experimental probability be the same? We don't know. Depends. We talked about that already. Okay, so this is one that you're going to see on your homework. Okay, now I want you to think about this. On Mother's Day, which is coming up, by the way, in a few weeks, just a little heads up. Huh? Is it May 12th? Or 13th? It's got to be 13th. I think 12th is Saturday. I think 13th. That's only like 2 weeks. Just a little heads up. On Mother's Day, 200 people will give flowers. 150 people will give a card. 400 people will give a gift. And 250 people will do nothing. Okay? What? You're in that 250? You at least say Happy Mother's Day, right? Like a hug or something? Okay. What is the theoretical probability of giving flowers? Now, before I do anything, what do I have to see? What do I have to see before I figure anything out, Henry? How many people there is total? So, geez, how many people do I have? 200, and I have 150, and I have 400, and I have 250. Is that it? Let's see, these two people equal 400, right? And this is 600. So how many people do I have here? I have 1,000 people. How many of these are going to give flowers? 200? Can I reduce this? By a lot. 1/5. So 20% of people are going to give flowers. That's in theory. That's on paper. Now, does that mean if I just randomly pick somebody that they're going to give flowers? No, that's actually a really low chance, isn't it? What has the best chance in here? The gift? Because what did they give? 400? So 40%, was that 40% of people? Yeah, it'd be 40% of people give a gift. And then 150 give a card. I would think that would be higher. I just made this up, by the way, so I don't know. There's going to be one like this on your homework. They're going to ask you something like this. They're going to make you figure out how many total people. They're going to ask you, in theory, what's going to happen. Then they might ask you about the theoretical probability. What might happen with theoretical probability? Well, what if I ask you that? What might happen with theoretical probability in this problem? In theory, is that, or in experimental, do we know? No, not all the time. So be prepared for that. All right, let's do some experiments, shall we? Let's talk about a coin first. We're going to flip a quarter. Okay? How many of you guys know how to flip a quarter? Like, not just like this. You, like, flip it and, like, put it in on your... You guys know how to do that? Okay. Not really? Well, you're going to learn something today. I told you you'd learn something every day, right? First of all, let's talk about coin. Let's talk about a coin. What do we know about a coin? Two sides. Okay? So, in theory, what's my chances of flipping a head? In theory, okay, so my theoretical probability is 1/2 for heads. Okay? Let's experiment. You guys want to experiment? It says 20 times. We'll do 20 times first. I don't know if I have one for everyone. I think here I do. You want to do it by yourself? You want to do it with a partner? What? By yourself? All right. Fine with me. What? Oh, you pennies. You flip pennies. Okay, this is what not supposed to happen. Was that you, Merrick? Here, let me show you. You're supposed to do it like this. You're supposed to do it like this. You're supposed to put it in your thumb, flip it, catch it, put it on your hand. And you write it down. So you're going to do it 20 times. You're going to mark down whether you have heads or tails. 20 times. Or if you don't know, just flip it on your desk like that. That's fine. Oops. See, that's what you're not supposed to do. I don't care what you do. Flip it 20 times. See what you get for your experimental probability. Oh, Kaylee. Keep watching. Oh, Jacob, you need you've been all over the place. What's it gonna be? Tails. You can just write T and H, American. T and H. You're doing it 20 times. This is a riot. You guys are funny watching do this. Tails. Oh, we need practice. Where did that go, Merrick? It's right there. Oh. What is it? Oh, it's tails. I think we need to have a coin flipping class. You can have a coin. Jeez, Merrick, what are we gonna do about you? Maybe we should put your chair in beside us to land on your chair. Tails. You guys, you are really bad. I wish I had a video of you guys doing this. That's all. Yours was really weird. Where'd it go? I don't know. You got it? Anybody see Eric's quarter? Yeah, he has it. We do? Is it on you or what? Yeah. can hardly flip it. More or less count to 20. It is a tails. We need to have coin flipping class. You're done? Okay, find the probability of heads and tails then. Out of your experiment. Now please don't steal my quarters because I use these to like washing my car. Yep, find your experimental. From your experiment, how many times did you flip your heads and your tails? Oh, we're gonna fall one way back here. It is a tails again. Every time you drop it on the floor, it's a tail. Do you really? That's crazy. That's not so bad. That's not so bad. 12 tails. Okay, so some of yours came up really close to theoretical on paper, what it's supposed to be. Some of you not so much. That's okay. That's the concept of to show you that in theory, what's supposed to happen might not always happen in your experiment. Exactly. So we got 50-50. Quite a few people. I'm actually really surprised that you came up that close. You still flipping over here? Heads. Let's see if Merrick comes up. I think he's probably got more tails. Every time it falls on the floor, you get tails. Well, not this time. Head. I did too. So you got 20? All right, count it up. How many heads do you got? How many tails? Maybe spitting like this from now on. You guys can do that better than you can flipping them. You guys are bad. We should all have. Well, I don't know. I think some of us should maybe start practicing for the TV. Remember, that's what big refs do in games, right? Don't refs, they have to flip the coin. Some of them fall on the floor. Yeah. So that fall on the floor. Oh yeah, something happened with the coin toss. You're right. Where it didn't do anything. It like went up and down, or yeah, something like that. All right, so 8 and 11. Okay. 8 what? That's only 19. That means you gotta do it again. That's only 19. 7, 8, 9, 20. You must have counted. You must have counted wrong because he's got 20. Okay, let's do another experiment. We're gonna do it this time. So put your coin to the side. Put your coin to the side. Okay, we're gonna do another one. Gonna do another experiment. Do you want to do it in groups? It'd be easier to do in groups. This one would be. Okay? So let's do this. So let's have like you come up, you, yeah, just come up to the person in front. Okay? And then do I have to have a group too somewhere? Does everybody have a group? There's 10 of you, right? Everybody should be able to be in a group. So who do we got here? You two, you two. Let's just put you two together. And then you two, and then you and Vega. Okay? So I'm going to give you 4 cards. Okay? Check to make sure the 4 cards, I'm not worried about the number, I'm worried about the suit. Okay? I'm not worried about the number. Check to make sure you have 4 different suits. No, oh no, just be your group. My bad. Okay? To what? Oh, it doesn't matter. I'm worried about the suit, not the numbers. Okay. All right. So you have 4 cards. Each of them are a different suit. I don't care which numbers they are. You're going to turn them around and you're going to shuffle them up. Okay. Now let's talk about, before we do anything, let's just talk about hearts. What's the probability you're going to pull a heart out of here? 1 out of 4. So 25%, right? That's in theory. This should be theory, and this is hearts. Okay? I'm going to have you pull a card from your deck 20 times, and you need to make sure you record what suit it is. You guys know the suits? There's clubs, there's diamonds, there's hearts, and there's spades. So make sure you record it. Make sure you're kind of shuffling every time, because we don't want the same card to come up all the time, all right? So keep track of what suit you're doing it 20 times with your partner. Okay? Ready, set, go. Yeah, you can do S's. Let's see. Spades, hearts, diamonds, clubs. You can just write the first initial. Spades, clubs, hearts, diamonds. Just wait, you gotta pull 20 times. It doesn't mean you're getting a spade every time. Uh-oh, that's not gonna be good. What? Just throwing it. Don't need it or anything. Oh my gosh, here we go. You haven't? What? How many got left? 3 times left? 7 times. Oh my gosh, don't even. You can't even handle it when you throw it up normally. Oh, you can? Wow. Oh, you guys are funny. About done? Okay, figure out. Let's just start with hearts. Figure out how many hearts you have. What was your probability of that? And then just go through and figure out all the other suits too. How many clubs, how many diamonds, how many spades. Did you write it down? Okay. All right, so figure out how much you have of each one. Heart, spades, clubs. If you think about it, each one would have had the same probability, right? Each one was a fourth. And that's called uniform probability. Remember, that's what we just talked about. That was one of our vocabulary words. Did anybody actually have anything that came out 5 times? Like anybody have anything that like sued? Anybody have any suit that actually theoretical probability? You had hearts 5 times. Spades 5 times. Okay. Okay. But in theory, everybody should have gotten 5 hearts, 5 clubs, 5 diamonds, 5 whatever else I'm missing. What am I missing? Clubs, spades, hearts. I don't remember. Clubs, diamonds. I don't remember. All of them should have the same probability. If in theory you should have had 5 of every single one. We know in experimental, is that always true? No, not always true at all. Okay, so that's what they're going to do in your homework today. They're going to give you a problem. They're going to say, what's the theoretical probability of this happening? Now, here's what we do for an experiment. What's the experimental probability? Now, to explain the difference between the two. Can you do that? Yeah. Do you guys have any questions for me? Yep. That you have to experiment with? No. So, why don't you, somebody collect, no wait, I want to keep the cards separate. So just leave it on your desk and I'll come around and pick things up, okay?